Well, okay. If our next team, Pavlo Radyuk, Olha Pavlova, and Nataliya are ready, so there you are welcome with your presentation. So you'll have more time for presentation and discussion then.
Yes, we are ready. If I may, I can. If you may, I can show my presentation. Just a second.
Yes, welcome.
Could you please enable sharing the screen?
So try it now.
Is it visible?
Yes, we can see it well.
Okay, thank you. So, greetings, dear colleagues. My name is Pavlo Radyuk. I am a PhD lecturer at Melnychuk National University, Melnychuk, Ukraine. On behalf of my co-authors, Olga Pavlova, PhD from Melnychuk National University, and Nataliya, PhD also from Melnychuk National University, I'm eager to present our work titled An Ensemble Machine Learning Approach for Twitter Sentiment Analysis. The content of our presentation is as follows: the motivation and state of the art, objective of the research, data preparation and feature extraction and representation, classification models that we used for investigations, results and discussion, and conclusion in the end. So, in recent years, dozens of businesses have conducted numerous sentiment analysis on Twitter to determine the attitudes of their users to a product or service, or analyze the market overall. It might be difficult for responsible staff to manually notice possible issues or even the crisis before it commences. Therefore, this study aims to investigate modern natural language approaches that may facilitate sentiment analysis based on textual data from Twitter to efficiently assess and predict possible reputational failures of a business or social entity in real time. Intelligent analysis of microblogging using machine learning and deep learning methods and means has become highly relevant these days. At the same time, since the type of textual data and the conditions for short text messages on Twitter constantly evolve, there is an urgent need to develop new techniques for semantic analysis of textual data on this platform, on Twitter. In this work, we investigate several classification models and propose a new ensemble machine learning approach to categorize the polarity of tweets based on their semantics into positive and negative classes. So the targeted data is prepared in files with two columns, text messages and corresponding labels indicating the message's semantics. The training subset comprised tweets ID, semantics, and emoticons that facilitated predicting polarity. URLs and user mentions were ignored and reformulated according to the pattern described in the paper. The words within messages are meant as a mixture of words and phrases with errors, extra punctuation, and words with lots of repetitive letters. After preprocessing, the prepared training and test data sets comprised 100 and 1,000 and 10,000 text messages for training and test data sets respectively. Two types of features from the used data sets, namely unigrams and bigrams, were extracted from the prepared data set. A regularity distribution of unigrams and bigrams was constructed. A total of 50,000 unique words as unigrams and 473 and 211 unique bigrams were extracted from the dataset. The top 22 unigrams and bigrams were selected after that for the sentiment analysis. This is because other unigrams and bigrams had no feasible impact on the vector, on the vectorization. The extraction of features into unigrams and bigrams resulted in two feature vectors, sparse and dense vector representations. The choice of the vector representation depended on the type of approach. Several machine learning and deep learning techniques, namely random forest, gradient boosting random forest, support vector machine, multi-layer perceptron, recurrent neural network, and convolutional neural network were implemented to categorize the sentiment expressions presented in a tweet. In this work, a long short-term memory was utilized. The maximum size of the input layer was set to 40, while the vocabulary size was set to 90,000 words. The temporal convolutions of 3 by 3 and a padding of 1 by 1 were applied to the convolutional architecture to process sequential data. In this work, as you can see, the main role was led to neural networks, as they showed better results according to compared to traditional techniques. And also several convolutional architectures with numbers of convolutions of 1, 2, 3, and 4 were explored. The maximum size of the input layer was set to 20 with a vocabulary of 70,000 words. A straightforward ensemble model based on previously mentioned approaches was constructed to improve the obtained classification results. We extracted a 600-dimensional dense feature vector from the penultimate layer of a 4-layer convolutional neural network. Specifically, this type of architecture, CNN architecture with 4 convolutional layers, demonstrated the best results compared to other approaches. As such, an ensemble of 5 different models was prepared, and the results were used in the majority vote of predictions. The figure in the slide illustrates the proposed ensemble model. The initial data set of 100,000 tweets was split into training and validation subset of 70 and 30% respectively. In addition, the sparse vector representation of tweets was applied to the random forest, gradient boosting, support vector machine, and multi-layer perceptron, while the dense vector representation was applied to the recurrent and convolutional neural networks. Based on the experiments, both neural networks showed better classification performance than other classical machine learning techniques. The best recurrent model achieved an accuracy of 84.303%, and the best convolutional model reached 85.52% of the test dataset. The fine-tuned 4-layer convolutional model obtained the best results with the support vector machine classifier, 85.52%, and the proposed ensemble model with the majority voting, 85.71%. It was also discovered that the convolutional neural network with the support vector machine classifier demonstrated better performance than just a single convolutional network. At the same time, the ensemble method, based on receiving the most votes according to the 5 best models predictions, reached the highest accuracy of 85.71%, surpassing the single deep learning models by more than 0.19% and demonstrated its practical usefulness. It should be also noted that the time for training required approximately 5 hours in total for the whole ensemble model, but each separate neural network required approximately from 30 to 40 minutes. Overall, this study aimed to address the issue of classifying emotional expressions based on small texts, in essence tweets, extracted from Twitter. According to the computational results, the considered techniques could efficiently facilitate sentiment analysis of tweets by assessing and predicting possible business outcomes on Twitter in real time. It was also investigated that biograms contributed to improving the classification accuracy and appearance in the sparse vector representation, recording a better performance than just a single regularity. The semantic analysis showed that tweets do not always have strictly positive or negative emotional expressions. Sometimes they may not have semantics, just being neutral, or have some range of semantics. Let's say very positive, barely positive, well positive, or something else. So further research will expand the number of categories of emotional expressions of semantics, for example, to classify moods from -3 to +3, or from -2 to +2. In addition, a more detailed linguistic semantic study of tweets on various real-world issues will be conducted. And probably more types of data sets will be extracted. So I appreciate your attention, and I am pleased to answer all the following questions. Thank you.
Thank you very much. Very interesting, very topical presentation. Dear colleagues, dear participants, you are welcomed with your questions to the speaker. Okay, well, if there are no questions, we move on. Well, and it's my pleasure to invite the next team of researchers, Oksana Melnychuk, Nataliya Bondarchuk, Ivan Bekhta, and Olena Levchenko with the presentation Quantitative Features of the Words Representing Nonverbal Behavior in Ian McEwan's Fiction. Okay.
Good afternoon, dear participants. May I share the screen, please?
Pavlo, will you please stop your presentation, please? Thank you.
Well, honorable participants of the conference, let me present the results of our research, which was conducted by Oksana Melnychuk, Nataliya Bondarchuk, Ivan Bekhta, and Olena Levchenko, the researchers from Lviv Polytechnical University and National Lviv University. So the topicality of the research is it doesn't go. Okay, so the topicality of the research is connected with the fact that the computer-assisted textual research reveals a set of quantitative features, absolute and relative frequency, quantity rank of the words which articulate the meaning of a fictional text. This meaning is expressed in words denoting nonverbal behavior in McEwan's novels Sweet Tooth and Solar, under the research framework of quantitative analysis, in particular computational text analysis. Reasoning. Any description of nonverbal behavior by a writer is ipso facto significant, since a creator of the fictional text would not record constant background noise and redundant paralanguage of everyday life. Novels by McEwan are the relevant sources of investigation of nonverbal behavior. Here we investigate voice qualities, which are called paralanguage, and different kinds of moving. Computational approaches to research this phenomenon exemplify accurate lexical and semantic data and stimulate integration of computational researchers and linguistics. The objectives of the research are to detect a set of quantitative and qualitative features of words revealing nonverbal behavior. They are paralanguage, moving, in corpora, to make a qualitative interpretation of results. The set of quantitative features is the following: absolute and relative frequency, quantity rank. The quantitative research of the words representing nonverbal behavior involves the application of the following methods. They are quantitative analysis connected with computational linguistics and the use of Voyant tools, qualitative analysis, which includes interpretation. The diagram shows the absolute and relative frequencies and the most frequent words in corpus 1 in textual segments. As we can see, the most frequent is the word sad. The next diagram shows the absolute and relative frequencies and the most frequent words in corpus 2 in textual segments. As we can see, the most frequent are the words and sad and calm. Under the present research, we took into account not only the words, but also the word forms for paralanguage and moving. Here we see these words: say, tell, talk, speak, sound as verb and sound as noun, voice for per language, and go, come, walk, follow, turn for moving. Mostly these words are verbs, but not nouns. All of the word and word forms were described according to two types of meaning. Descriptive, it describes voice or movement, for example, to say coolly, to tell in a flat voice, to go slowly, to turn minimally. And non-descriptive meaning. It doesn't describe voice or movement, but it has transferred meaning. Was going to see, it would come soon, to go mad, had drinking came, to follow the logic. We should know that a descriptive meaning prevails in British contemporary fiction. So the rank in Corpus 1 and Corpus 2 is approximately the same. The first word in Corpus 1 and Corpus 2 is say and go for non-descriptive and descriptive meaning. The last word in both corpora is talk and work, tell respectively. To sum up, the set of quantitative data of the present research is the ground for further development of software for linguistic tasks to study the author's writing style. Supplemented by the data about collocations, obtained practical results might contribute to the study of corpus linguistics, in particular to compile a corpus digital dictionary of words and word forms of nonverbal behavior represented in contemporary British fiction. Thank you for your attention.
Thank you very much. If there are any questions, so
if I may, I have a question,
Mm-hmm.
a small one, to Oksana. What methods did you use to conduct quantitative research? I mean, to extract quantitative features?
Also, thank you for your question. We used the method of computational linguistics. We used Voyant tool. It is a tool that is available through GitHub. We used this tool for automatic generation of diagrams and automatic reception of necessary data.
Got it. Thank you.
Okay, thank you.
Oh, any more questions? Okay, so the next team of researchers, Yuri Krivenchuk, Alina Yamnyuk, Irina Potsik, Lesia Sai, Andriana Mazur, and Olena Sidorchuk with the topic Random Forest as a method of predicting the presence of cardiovascular diseases. Okay. Are these participants present in our meeting?
Seems that they are absent, they are not here.
Well, they are to speak at 3 o'clock. A bit
Behind the time, yeah.
yes. So shall we invite other speakers or make a break? Well, okay, Halyna, Tesliuk, and Olha Kulyna. Okay, maybe.
Yeah, we are here. I will share the presentation. Thank you very much for having us here. I will share the presentation and then Halyna will start and then I will take the floor.
Shall I begin?
Yeah, just a minute, it's loading. Yeah.
Okay, so good afternoon, everyone. It's my pleasure to be among you today. I'm coming from a completely different discipline, that's theology, biblical studies. And I am pleased that we've managed with Olha, Kulyna to make this interdisciplinary contribution. And thank you for the accepting our talk and our paper within this intellectual endeavor. So our topic is public health as a social phenomenon from a biblical perspective, automated identification, and why we have chosen the topic and try to use Olha, it's not moving. It's still the first slide, if you could. Okay, thank you. We decided to talk about this and use the tools, the IT tools to analyze it, because we in humanities need IT help to collect the data, to analyze the data, and to have it presented in a scientific way. So, what is public health? In our aim of our article is to define the issue of public health as a science, and also to create an overview of public health perception in the Hebrew Bible or Old Testament. Public health is the science that aims to protect the health of people and communities multidimensionally and holistically. This is accomplished by promoting healthy and environmental friendly lifestyles, providing equal access to the medical services and care, researching and detecting various diseases, preventing and addressing the emerging infectious diseases. And there are many other questions that actually public health as a science is dealing with. Many scientists have recently put their interest in the discussion of public health, and usually they distinguish 4 key factors that affect the health of the community. They are physical factors like geographical location, environmental situation, community size, industrial development, social and cultural factors such as religion, traditions, economy, politics, and social norms, community organizations such as how community is able to mobilize and work together, and finally, individual behavior. That's the responsibility of each of us for the well-being of other members of our community. Religious stance plays an important role how people react to the state policies of public health. For instance, some religious groups do not accept the possibility of blood transfusion for a sick person. Some prohibit immunization or even to be treated by physicians. And some discuss the moral issues of abortion and euthanasia. And if you look at the studies that have been done from a religious perspective on the issue of public health, and there is one great scholar, George Rosen, he is the forefather of public health and its history. He is in his seminal work, A History of Public Health, traces the concern of human health back to the time of ancient Mesopotamia and Egypt. However, he only briefly mentions the text of Hebrew Bible and Old Testament, which is very rich in its treatment of the issue of public health. So if you look at the Bible, you will see lots of religious laws, but still they are very public health laws and precepts, as so to say. So the biblical laws and precepts are religious in its nature, yet they aim at the physical and mental well-being of the chosen people. In other words, what one finds in the Hebrew Bible is a compendium of instructions for a community how to organize and preserve its own health. It should be noted that there is no dichotomy between the soul and body in the Hebrew Bible. A human being is perceived as one entity, a one living soul. As Larry Paul Logan correctly observes, in regard to illnesses, a human being, cannot be ill only by body, it also and healthy in mind or soul. So it's a very holistic way or look at the health and the well-being of human person. In Hebrew word, the Hebrew word shalom describes the harmony of relationship between humans and can be translated as peace and prosperity. And this is what describes the harmony of relationship between humans and God, humans and environment. It also refers to the holistic view of the life of an individual, including his or her health. To live holistically or healthily, in biblical terms, mean to eat clean food, or to avoid what is forbidden, to moderate the amounts of alcohol, to keep hygienic rules, and to avoid contact with the corpse, go into quarantine if someone diagnosed with a skin disease, and other possibly infectious diseases, to take a rest from work. So it takes discipline to be healthy, maintain one's mental health, and to remember that keeping the laws is a responsibility towards own community. So in order to show how the Bible looks at the public health, we used a tool that helped us to collect and analyze the data. And that's the next slide. So this is the text that we used, the Hebrew Bible translation of the Hebrew Bible into English, and the tool we used, Olha, could you please move on to the next slide? A sketch engine. And this engine actually helped us to catch the words that are key and important for the public health topic. And it helped us to identify the frequent usage of the lemmas and how it can be later on understood and perceived. Now I'm turning to you, Olha.
Yeah, okay, thank you very much. So I will move on. And then what we suggested, then we proposed two hypotheses to be tested. So the first hypothesis has been applied to single out the most appropriate nouns which denote the meaning of public health in Hebrew Bible. So this hypothesis will be tested by a comparative analysis of collected data, their statistics and classification. The second intended to see a word sketch with the most typical combinations by processing words with collocations and other words in its surrounding. So the results are to be organized into grammatical categories, such as words that serve as an object of the noun, words that serve as a subject of the noun, words that modify the noun used with and or, prepositional phrases, adjective predicates of the noun, pronominal possessors of the noun, and verbs used with the noun. So related to the prior research, health, according to it, is taking care of quality of life, living in peace with God, others, and self, eating healthily, and being moderate with alcohol, taking care of the body and its hygiene, remember to rest and give others this possibility, bring others joy and encouragement. So let us consider public health based on the keywords singled out from this concept. And on the screen here, we have the diagram and we can see the results. So these words are life, blessing, peace, health, clean, unclean, rest, and joy. The total number of words is 1,164, and among them, life, peace, rest, unclean are used the most, and then joy, clean, and blessing take important positions in the group. So then let us have a look at grammatical relations of each concept. So it's their first step, what we suggested to do. So to see the surroundings, how these words are used in the context. So these relations can be as following. Words that serve as an object of the noun, words that serve as a subject of the noun, words that modify the noun used with and or, prepositional phrases, adjective predicates of the noun, pronominal possessors of the noun, and verbs used with the noun. And so on the screen, we can see the second diagram, which demonstrates grammatical relations of life. So 9 grammatical relations are used in this category. The total number is 177. So among them, we have modifiers of life. I'm not going to come with the numbers because we can see the numbers. So among them, we have modifiers of life, verbs with life as object, verb with life as subject, life plus and or, prepositional phrases, adjective predicates, possessors of life, pronominal possessors of life, and verbs with particle away and life as object. So verbs with life is object, prepositional phrase, and pronominal possessors of life are considerably larger in number than other grammatical relations. Now we will move on to figure 3. So this figure presents 8 relations of verb blessing in the text of corpus. So the total number is 76. So these are modifiers of blessing, noun modified by blessing, verbs with blessing as object, verbs with blessing as subject, blessing plus and or, prepositional phrases, pronominal possessors of blessing, verbs with particle away, and blessing as object. So this group is remarkably shorter than the previous one, and the majority in the group is given to prepositional phrases. So let's move on to the next figure. So figure number 4 provides information on the grammatical relations of peace. The total number of these relations is 283, which are singled out into 10 categories. So these categories include modifiers of peace, noun modified by peace, verb with peace as object, verb with peace as subject, peace plus and or, prepositional phrase, then the phrase peace is, and then provided what it is, pronominal possessors of peace, then phrase something is a peace, and verbs with particle away and peace as object. Peace most often is used with prepositional phrases and verbs with peace as object. So figure 5 shows the next grammatical relations of clean. It has 110 following combinations, which are structured into 7 groups. So we can see the groups on this slide. So these groups are modifiers of clean, noun modified by clean, clean plus and or, prepositional phrases, verbs complemented by clean, verbs before clean, and subject of be cleaned. The next figure introduces a grammatical relations of uncleaned and is grouped into 6 relations. So nouns modified by unclean, unclean and or, prepositional phrases, verbs complemented by unclean, and verbs before unclean, subjects of be unclean. Total number in these relations is 170. Another grammatical relation is rest, which consists of 108 relations, singled out into 8 groups. Modifiers of rest, noun modified by rest, verbs with rest as object, verbs with rest as subject, rest plus and or, prepositional phrases, pronominal possessors of rest, verbs with particle, unto, and rest as object. So the smallest in number is grammatical relations of health, only 20 relations which are grouped into 4 types. So and here we have verbs with health as subject, health plus and or, prepositional phrases, and something is health. And now we come to the last relations. So this is the relations of joy, and they are presented on this slide. So here we have 8 groups, and all in total we have the number of 139 relations. So among them we have modifiers of joy, nouns modified by joy, verbs with joy as object, verbs with joy as subject, joy plus and or, prepositional phrases, pronominal possessors of joy, and then the structure something is a joy. And now we come to the conclusion. So the result of the research have shown that public health played an important role for people back in history. So it is not only the phenomenon that is popular nowadays, and particularly during the COVID period time. In Hebrew Bible, we came across with many examples of health issue. So both hypotheses were tested and both of them were proved. So the first resulted in singling out the most appropriate lemmas denoting public health. And here we have life, blessing, peace, health, clean, unclean, rest, and joy. The results show that life, peace, rest, unclean, joy, and clean are the most frequently used lemmas to denote health. And the fact that lemma health was used only 9 times, so all in total 0.77% was quite surprising. So this hypothesis was tested by a comparative analysis of collected data using a statistical approach. So the second hypothesis also was proved successfully, and it outlined grammatical relations of each lemmas to the most typical combinations. And the result we could see on the slides in the form of the diagrams. Thank you very much for your attention.
Well, thank you very much. We have 3 minutes. Maybe we can use them for questions and then procedure or rejoining. Okay, dear colleagues, any questions to the presenters, to the speakers? Well, very topical theme, well, the health.
Yeah, so when we started working on that topic, it was during the COVID period time, and it was on the time, and now we have other important issues, yeah, more important than that. Yeah, and what we really would like to do next, then to compare the results that we have with something more modern, for example, like other European laws related to health, and to collect the corpus of such documents and to compare the results with what we have now. So I think it also would be interesting.
Okay. So then I stop this meeting and we will rejoin.